Hey guys, so in this video I'm finishing our quiz review, our Honors Math 2 quiz review for Unit 1. So looking at number 2, looking at this funky graph, we are looking at our domain. This is not a typical quadratic, so we are not looking at it. This is not a quadratic at all. So we cannot use our trick of all of our domains being negative infinity to positive infinity. Our smallest x value involved is -7, so -1, -2, 3, 4, 5, 6, 7. So our domain is going to start at -7 and is going to go to the right forever and ever, so positive infinity. Then our range, we're going to start at our smallest y value, which is at -3. And we're going to go up forever, slowly but surely. So we're going to go to positive infinity. Then we're looking at our min or max. We have a minimum because we can pinpoint our smallest point. We cannot pinpoint our largest point because it keeps on going up forever. So we have a min, and that min is located at -7, -3. Then our x-intercept is here, is at 2, 0. So then we have our increasing versus decreasing. There's not two parts of this graph. There's only one part, and it is constantly increasing. So the whole graph is increasing. There is no decreasing interval. So our smallest x value is still at that -7. So there's a point, -7, and we're going to go to the right forever, so we're going to go to positive infinity. Due to the fact that there is no decreasing interval or no place on the graph that it's decreasing, reading left to right, we can put none or no or whatever you want to put to tell me that there is none. Do not put 0. Do not put 0, 0. Do not put infinity. That would be wrong. There is no interval at all. Once you put 0, you're telling me that there's an interval of 0 to 0 or infinity to infinity for this graph, and there is not. So then we have our y-intercept. Our y-intercept is located here. It is approximately 0, -0.5. As long as you give me a decimal and it's smaller than 1, I'm okay with it. Now, if we are working with the equation and not the graph, or if we were given the equation and not the graph, then I would be expecting exact decimals. Now, to look if it is a function or not, we are looking here, and we can draw our random vertical lines, or we can drag our pencil across the graph. As long as the graph doesn't intersect any of these lines or your pencil more than once, it is a function. All right, number 3. Number 3, we're going to put into our calculator to get the graph. So to get this, we need to go to y equals on our calculator. To get that absolute value bars, you're going to go to math, arrow over to the num or number, and select number 1. It says abs and there's a parentheses. That's what you want. And then you're going to hit or type in x plus 2, arrow over to get out of the absolute value bars, and then subtract 1. Then we're going to go to second graph to go to our table. Now, on my paper, I'm going to write a few extra points so we can talk about which ones I would graph specifically. So here's your x values, here's your y's. We have -5, 2, -4, 1, -3, 0, -2, -1, -1, 0, and 0, 1. Excuse me, guys. I don't know what just happened. There we go. And -2, -1, negative -1, 0, 0, 1, and 1, 2. So we want to determine 3 points that includes where our y values change direction. So what do I mean by that? In between 2 and 1, we are going down. In between 1 and 0, we're going down. In between 0 and 1, we're going down. And in between -1 and 0, we're going up. Well, right here, it changes directions. So as long as you have -2, -1, and -1, 0, I don't care which points you plot. As long as there's 3. You have to have 3. So I'm going to select -3, 0, -2, -1, and -1, 0. So I'm going to graph that on my graph. I have -3, 0, so left 3. Then I have -2, -1, so left 3, down 1. And then I have -1, 0, so left 1. So there's my graph. Now, on my answer key for any assessment, I'm going to have different points or multiple points on my answer key so I can check your points if you chose another 3 points. So then I'm going to connect these and extend it so I can look at my full graph. And it's going to look like a V. So then we got to determine our key features. So first thing is domain. We're going to go to the right forever and the left forever. So we have negative infinity to positive infinity. Then looking at our range, looking at our y values, our smallest y value involved is -1. And there is a point where y is -1. And we're going to go up forever. So we're going to have positive infinity as our biggest y value. Then we have a min or a max. Smallest point is at -2, -1. That's our min. Our x-intercept, we can either use our calculator or we can just look at our graph because we can look at specific points. Our x-intercepts, where it intersects the x-axis, is at -3, 0, and -1, 0. We can split up our graph into 2 parts to determine our increase and decrease interval. On the left side, it is decreasing. On the right side, it is increasing. So for our increase, we're starting at -2, going to the right forever. For our decrease, our smallest x value is -infinity on the left side, and then we're going to decrease until we get to x is -2. Y-intercept, we can see very clearly that is at 0, 1. And then if we dragged our pencil across, the graph would only intersect our pencil only once. So it is a function. And that is for number 3. Number 4, we are determining our transformation. We're determining our parent function. And we are graphing them. So I'm only going to do these. I'm going to do one very slowly, but then I'm going to do the other ones very quickly. So first one, Our parent function is y equals x squared. The reason why I know it's x squared is because of the squared up top. Our 1/2 is less than 1, so I know it's a compress. It's going to compress the parent function. Then I have a -5 on the inside. If it's on the inside, we're going to do the opposite of the sign. So we have right 5. And then we have -4 on the outside. If we're on the outside, we're going to be obedient to the sign. So we have down 4. And then we can graph this. Now, for 5, I'm going to just focus on these transformations. You can graph this on your own time. If you need help graphing it, please email me. Number 5, parent function, again, is y equals x squared. Our negative outside is going to tell us to reflect over the x-axis. Our 4 is greater than 1, so we're going to stretch. We have nothing on the inside, meaning nothing with the x adding or subtracting. So we're not going to go left or right, but we do have a +2 outside or away from the x. So that is telling us to go up 2. Because we're going to be obedient to it because it's not with the x. Number 6, parent function, y equals x squared. We have a 4 out front. It is greater than 1, so it is going to be a stretch. We have a +3 on the inside. That's going to be a left or right. It's going to be opposite of the sign, so it's going to be left 3. And then we have a subtract 7 or a -7 outside. That's going to be up or down. We're going to be obedient to the sign, so we're going to go down 7. Then lastly, number 7, parent function is y equals x squared. Our negative is telling us reflect over x-axis. Our 2/3 is less than 1, so it is going to be a stretch. Our subtract 6 or -6 is on the inside. If we were going to be obedient, it would be left 6, but we're disobedient inside, so we are going right 6. And we have +1 on the outside, obedient to it, we're going to go up 1. So those are your transformations for 4 through 7. And then on the graphs, all you're doing is graphing the transformation. So you're going to graph what is there. If you need help with that, please email me and I will help you.